Hey, GED students. I had a student working on the advanced level practice of the area of composite shapes. And Robin, she got to the end where there are some pretty challenging problems, got a little stuck. So good news again, as usual, with Miss Robin. This is probably a little more challenging than what you're going to see on the GED, but it is a great practice for looking at area of composite shapes. So let's go ahead and take a look. It says the Murakami family is doing some improvements around the house before selling their property. Okay. They plan to reshingle the roof, install vinyl siding on the front of the house, and repaint the garage door. Refer to the front elevation below. Okay, so there's a picture of the front of their house, and it says the new vinyl siding will be applied to the entire front of the house. Okay, we're going to apply vinyl siding to the entire front of the house, except the 8-foot by 16-foot garage door. We're not going to put vinyl on the garage door. And the 4-foot by 4-foot attic window. That makes sense. We wouldn't cover the attic window. And then we want to know how many square feet of vinyl siding would be needed. So a couple things I want to point out. First of all, we're looking at how many square feet. That's a really big clue that even if we weren't working on an area worksheet per se, we are looking for the area of the front of this house. Now let's look at the front of this house. It's definitely a composite shape. You can see that the front of the house is composed of two big shapes. We have a triangle and we have a rectangle. Basically, that's the basic idea here. So we're going to cover the triangle in vinyl siding. We'll do the area of the triangle, and we're going to cover that rectangle with vinyl siding. We're going to do the area of the rectangle. But both of those shapes have places that we are not covering. So on the triangle here, we are not going to cover the window. This little square window is going to get taken out. It's not going to get covered. So I'm actually going to minus the area of that square. And then same thing with the garage door. We're not going to cover any of this garage door here with siding. So I'm going to take out the area of that rectangle. So that's a lot of planning. I'm going to put in the area of the triangle, take out the area of the square, put in the area of the rectangle, take out the area of the small rectangle. That's a lot going on. Let's go ahead and start the work we've planned. First, let's look at the area of this triangular piece up here. And you can hit up the GED formula sheet if you need to, but to find the area of a triangle, you do 1/2 times the base times the height. I'm going to use the decimal approximation for 1/2, 0.5. My base is going to be one of my sides here. In this case, this 26 feet. And I hope you can see where I got that from. I know that this must be congruent down here to the bottom of this rectangle. And so the base of this triangle is 26. Now, the hard thing, though, is the height. The height is from here to here, like the height of the house. And we don't have that marked, but we do know something. We know that the bottom part of the house is 10 feet and that the house in total is 20. And so this remaining piece here, this height, must be the entire 20, take away the 10 I'm not using, or it also has a height of 10 feet. Awesome. So I'm going to do that to find the area of the triangle. So 0.5 times the 26-foot base times the 10-foot height gives me a total of 130 square feet. But that being said, we're not going to cover over the window. So I'm going to take out the window. So this is the roof, and this is the window. Maybe I'll label my work. Okay, that window is a square. It's a 4x4 square. So 4x4 or 4 squared gives me a total of 16 square feet. So I'm going to take that 16 feet out since I'm not covering it. 130 feet minus the 16 gives me 114 for that top portion of the house, the triangular portion. Lovely. Now let's look at the bottom portion of the house. This is basically a big rectangle, take away a small rectangle. So super easy to find the area of your rectangle. You just multiply the two dimensions. So I'm not even going to use the formula. I'm so lazy. The big rectangle is a 10 by 26. So I'll multiply 10 by 26. And from that, I need to take out the small rectangle. And the small rectangle, the garage door, is an 8 by 16. So I'll subtract out an 8 by 16 shape. Okay, so 10 by 26. The area of the front of the house was 260 square feet. But removing out the area of the door I'm not covering, that's 128 feet. Let's do that subtraction. 260 minus 128 gives me 132 square feet for the bottom portion of the house. All right, so if I'm covering 114 square feet up top and 132 square feet on the bottom, and I want to know the total, I'm going to need to go ahead and add those numbers. So 132 plus 114 gives me a total of 246 square feet. And no wonder you wanted me to do that one, Robin. That was nasty. Now, like I said, this one's probably more challenging than what you'll see on the GED. I really honestly don't expect to see anything with more than 2 or 3 shapes composed. In this one, we are looking at a composure of 4 shapes with both addition and subtraction, a little more trickier than you might see, but definitely comes up in real life. I mean, these are the kind of tasks we do with composite shapes in real life. So certainly useful to know. If you have any questions about this or any other GED math topic, be sure to drop it in the comments and I'll do my best to answer it.